Okay, boys and girls, today we're going to look at solving absolute value inequalities. Now, these are very similar to what we did in the previous video on solving absolute value equations. To solve them in Desmos is going to be very similar, but there's a couple of things we need to add. So before we do that, let's just kind of review for a second on graphing and inequality. So let's recall if we have x is less than 3. Now this does not have less than or equal to, so if it's x is less than 3, we're going to put an open circle on 3 because it's just less than. And where are they less than? They're less than to the left of 3. Okay? So if I have x is greater than -1, again, that would be an open circle because it's just greater than, shaded to all the numbers where it's greater than -1, which would be to the right. But then if we have x is less than or equal to -2, because of that less than or equal to, because of this line, that line makes our circle closed. So less than or equal to -2, I'm going to put a closed circle and then I'm going to shade to the left. Greater than or equal to 2, I'm going to put a closed circle on 2 and shade to the right. Okay? Now, when we're graphing inequalities, absolute value inequalities, when it's less than, I'm going to shade below, or what is below the line is going to be my solution. When it's greater than, what above the line is going to be my solution. Same thing here. My solution will be below the line of 2, and my solution here would be above the line of 2. And I have to kind of show you what I mean. But let's go back and look at some other stuff. Let's think about this for a second. Now remember, I've told you an absolute value is the distance the number is from 0. So which of these numbers on the number line will make this true? Would 0 make this true? Is 0 less than 3? Yeah, 0 is less than 3. When I take the absolute value of 0, it's less than 3. What about -1? The absolute value of -1 is 1. 1 is less than 3, so that makes that true. -2, the absolute value of -2 is 2, so 2 is less than 3. That makes that true. The absolute value of -3 is 3. Now that does not make it true because it's not less than or equal to. But I'm going to put a circle there because I can get very close to that -3. What about -4? No, that doesn't make it true because the absolute value of -4 is +4, and 4 is not less than 3. Will 1 make it true? 1 is less than 3. 2 is less than 3. And again, at 3, I'm going to put an open circle. 4 is not true, 5 is not true, nor is 6 or 7. So all the numbers that are true are between -3 and 3. All of the numbers between -3 and 3 make that true. So I'd write that as -3 is less than x is less than 3. That's how I would write my solution. And by the way, I didn't mention this, but we're on page 19 of your notes. What about x is greater than 3? What numbers make those true? Well, let's start at 3. Is 3 greater than 3? No, but it's kind of close to it. What about 4? 4 is greater than 3, so it's 5, 6, and 7. So I see that all the numbers greater than 3 make that true. What about 2? No, 2 is not greater than 3. Neither is 1, 0. Okay, what about -1? When I take the absolute value, I get 1. Is 1 greater than 3? Nope. How about the absolute value of -2? Is 2 greater than 3? Nope. How about -3? Well, we're starting to get close again, so I'll put an open circle there. What about -4? Yes, because -4, the absolute value of -4 is 4, so 4 is greater than 3. The absolute value of -5, which is 5, is greater than 3, so it's 6. So we see that all the numbers to the left make that true. So notice the difference. This is less than, And with greater than, we have, what you're going to have with greater than is the word or. I know it's spelled ER. But you want to look at greater than, and so we're going to have x is less than -3, or x is greater than 3. And that is how we solve those. Now, how do we solve that with an inequality? Well, let's look at that. I'm on page 20. So I'm going to graph this. The absolute value of x is less than 2. So I'm going to graph, if you look at the chart, I'm going to graph the absolute value of x. And then we want to say it's less than 2. So I'm going to set y equal to 2. If I can. Okay, there we go. All righty. All right, so where is it less than 2? It's less than 2 below the line. So I notice that it intersects at -2 and 2. So all the places below that line, so I've kind of sketched it here so you can see, all the places below the line, you can see this is where the solution is. And that's between -2 and 2. Can I make that bigger? So between -2 and 2 is my solution, just like we thought it would be. So I'm going to graph between, now this is less than or equal to, so I have a closed circle, shaded in between. And I would write my solution as -2 is less than x is less than 2. Less than or equal to. Alrighty, when we do greater than 5, so now we're going to do greater than 5, the absolute value, and I'm going to keep that the same. That's 5.2, but you get the point. So we see everything below, everything above that 5 is going to make it true. So that everything above 5, but between the absolute value makes that true. So we can see I've sort of graphed it here. So again, what we're going to get is -5. No, I'm sorry. What we're going to get is x is less than -5, or x is greater than 5. And when we graph that, we put an open circle, shade to the left, an open circle, shade to the right. It's the same thing if we have x minus 2. Take this one off and make x minus 2. And this time we're looking for less than 1. I'm going to leave that slider alone because I'm not very good at it. And we're looking where it is greater than 1. And so what are our solutions? Our solutions are 1 and 3, which I've graphed here. And it's that space between the line and the absolute value. So where it's greater than 1 and greater than 3. So we see that it makes a disjunction again. So where x is less than 1, or x is greater than 3, greater than or equal to, because of that. And so x is less than 1. I'm going to put a closed circle on 1 and shade to the left. I'm going to put a closed circle on 3 and shade to the right. And that's how we do those. So it's very similar. To find the numbers is very similar to what we did before. So we have 2 plus the absolute value of x plus 1, and we're looking when y is 5. It's less than. So because it's less than, we're looking for the values that are inside that v. So they go from -4 to 2. And because it's less than, we're going to say -4 is less than or equal, no, just less than x is less than 5. And if it's less than, we graph in between. So we put a open circle on -4, an open circle on 5, and we graph in between. I'm sorry, that's not 5, it's 2. Let me just relook at, and I have it written there. So that should be 2 and shaded in between. Okay? So what I'd like for you to do is I would like for you to pause the video and do problems 5 and 6, if you will. Okay? Welcome back. Problems 5 and 6. You should have gotten, let's see, 3x plus 1 and y is equal to 12. Y is equal to 12. It's all the way up here. Okay, so we're going to get the values of -5 and 3. And it's greater than, so we're going to shade less than -5, less than or equal to -5, greater than 3. And so we write x is less than -5, less than or equal to -5, or x is greater than or equal to 3. And for the next one, I didn't do it, 2x minus 3. So we go here, and we change this to 5. And we get 2 and 4. So we get 2 is less than x is less than 4 because it's less than. And if this is 0, we got 2 and 4, open circles and shaded in between. Okay? All right. So I would like for you to try, so for number 7, I didn't ask you to do that, but for number 7, that's what we get. I did it by hand just because it was easier for me. But I do want to show you number 8 and number 9. Those two are a little interesting. So for number 8, we have 2x, and that's up here, 2x plus 1 plus 8, and it's less than 0. Okay, now, when is this function, let me make this bigger, when is this less than 0? This is 0, is down here. When is this less than 0? When will this cross 0? Never. So therefore, we say that this has no solution because it would never be below 0. So it has no solution. But if we go to the next one, and we have x minus 8 minus 3 and -10, okay? So x minus 8 minus 3, I have another one graphed somewhere that, oh, it's right here. Okay. And so we're looking for when is this less than, or when is it greater than -10? So this is -10, the blue one. When is it above -10? Always. So we say this has all real numbers. And really we could graph this, the way we would graph this, we would just graph the entire number line to show that it includes every value. So it doesn't matter what value we put in here, it's always going to be greater than -10. So therefore, this has all real number solutions. Okay? Go ahead and pause the video and do the last 3 problems. Okay, welcome back. And these are the answers to the last 3 problems. There we go. These are the answers to the last 3 problems. And I hope this made sense. I know I kind of went through it quickly, but basically you're going to graph it. You're going to graph the equation. Graph the equations, and you're going to find intersections. And if it's less than, you're going to write it as A is less than X is less than B. If it's greater than, you're going to write it as A is less than negative. A is less than negative X, or you're going to write it as X is less than A or x is greater than b. And of course, if you have less than or equal to, you put the correct symbol there. Okay? That is that's how we graph these. And I